Okay, we'll look now at the quotient rule. So the product rule was used whenever we had two functions that were multiplied together, and now the quotient rule we use whenever it's division. So if y equals f of x over g of x, where there are two different functions, then, okay, so now I'm taking down the exact notation is used in your formula booklet, so you don't have to learn this, you just have to know how to apply it. dy by dx equals, so this means that the differential of f times the function, the g function, take away f times the differential of g all over g of x all squared. So first example then, differentiate y equals 3x squared minus 1 over 2x minus 1 all cubed. So this is our f of x, and this is our g of x then in the formula. So dy by dx equals the differential then of f of x. So we're going to differentiate the top line and we get 6x times just the bottom line then, g of x, 2x minus 1 cubed, minus, now this time it's f of x, so that's 3x squared minus 1 times the differential of the bottom line. So when we differentiate that, it's the function of a function, so it's 3 upon 2x minus 1 squared times 2, and that's all over 2x minus 1 cubed all squared. Okay, now you'd be expected to tidy it up a bit more than that, so the very minimum would be that. Okay, so we've got 6x upon 2x minus 1 all cubed minus 6 upon 3x squared minus 1 upon 2x minus 1 all squared over 2x minus 1 to the power of 6. Now I'm going to go through other tidying up that you could do. So I would take out 6 and I would take out 2x minus 1 squared, so I'd be left then on the top line with 2x minus 1 minus, sorry, I'd be left with 2x minus 1 upon x, forgot about that x, minus 3x squared minus 1, and that would all be over 2x minus 1 to the power of 6. So tidying that up, we would get 2x squared minus x minus 3x squared plus 1, and that's all over 2x minus 1 to the power of 6. Now hopefully you can see we've got a squared here and we've got power of 6 on the bottom, so I can cancel that out and I'd just be left with 2x minus 1 to the power of 4 on the bottom. And tidying up this bracket here, I get 1 minus x squared on the top line. Okay, our second one then, find any stationary points of y equals x over the square root of 2x minus 1. So the first thing, so I would write that as x over 2x minus 1 to the power of a half, and differentiate using the quotient rule. So this is our f of x, and this is our g of x. So we have differentiate the top, and we get 1 times g of x, 2x minus 1 to the power of a half, minus, now differentiate, sorry, just write f of x and differentiate the bottom line. So it's function of function, so it's a half upon 2x minus 1 to the minus a half times 2 all over g of x, which is 2x minus 1 to the power of a half, all squared. And we're going to tidy it up a bit. So 2x minus 1 to the power of a half times 2 would give you 1 minus x upon 2x minus 1 to the minus a half, all over 2x minus 1. Now we want to know what the stationary point or the turning point is. So for any stationary point, dy by dx has to equal 0. Now for this to equal 0, you would just say the top line would have to equal 0. Okay, then we need to do a bit of tidying up here. So I'm going to take 2x minus 1 to the minus a half out as a factor, and I'd be left with 2x minus 1 here, and I'd have minus x here. So tidying that up, this second bracket here would become x minus 1. I'm going to bring this bracket down, so 2x minus 1 to the power of a half would be on the bottom. So for this to equal 0, the top line would have to equal 0, which would mean that x would be 1. We then need to find the y coordinate. So remember, that's our formula for y. So it's 1 over 2 1s are 2 minus 1, that's the square root of that. So that gives you 1, so our stationary point is just 1, 1.